Hi, yes, good evening. Can you hear me? Hello.
Yes, good evening, sir.
Yeah. So thank you. So let us start session. Yeah, sorry for delay. Some network issue at my side happened. Yeah. Now it's okay, fine. Let us start session. Get into regular network, Wi-Fi. Yeah. So let us start. Yes, previous class, all the basics completed. Yeah. So last two sessions, introduction software. So this is the first session, system software, application software, and about front end, back end, explained. Low level language, high level language, they are software basics. Low level, high level languages. Yes. So next, yesterday session, interpreter and compiler. Yesterday session. Next, Java. Java depends on both compiler as well as interpreter. So Java, yesterday, just little bit introduction given. Java depends on both compiler as well as interpreter. Okay. Suppose here, C and C++, these are compiler. So they're compiler based here. Suppose next interpreter. HTML, Python, they are interpreter based. But Java both. Java depending on both. Java compiler as well as interpreter both here. In Java, source code to byte code to binary code. Then processor finally getting output. So first step, source code to byte code by the Java compiler. Byte code to binary code by the Java interpreter. So these topics yesterday discussed. So compiler, error seeking by the compiler, program execution by the interpreter. So two things involving in the Java. So these two things involving in Java. So Java is a both. Java depends on both compiler as well as interpreter. Java depending on both compiler as well as interpreter. So up to this completed. Okay, fine. Today topic, very interesting topic. Okay. So features of Java. Yes, tomorrow we'll discuss about these independent platform portable these things here. Tomorrow going for Java installation and Eclipse setup and all that here. So yes, with today topic is the theory concepts finishing, initial topics. Tomorrow we are going for Java installations. Okay. Yes, features of Java, initial features of Java. See JDK 1.0, first version of JDK 1.0 is the first version of Java. JDK 1.0, yes, first version of Java, first version of Java, first version of Java, released, released, released in the year 1996. So JDK 1.0 just is first version of Java released in the year 1996. First version of Java in the year 1996. Okay. So the first version, this JDK 1.0. So first version released with below features. Released with below features. So JDK 1.0 released with below features. So version-wise features we'll discuss next. First, initially 1.0 features. Next 1.2 version-wise, as per the topic we'll discuss. By the time of finishing core Java, yes, up to Java 8, all versions finishing here. Okay. Now first version features. JDK 1.0 released with below features. Okay, first one. Yes, Java is an independent of Java is an independent. Yes, independent. Java is an independent platform. Java is an independent platform. Java is an independent. So first one. Java is an independent platform. Java is an independent platform. Right? Second one. Yes, Java is a portable. Java is a portable. Next third one. Yes, Java is an object-oriented programming language. Java is an object-oriented programming language. Java is an object-oriented programming language. Next, Java is a scalable. Java is a scalable. Java is a scalable. Next fifth one, yes, Java is a secure. Java is a secure, right? So these are, yes, initial features of Java. Later I added many features. So these are initial features. Okay, these are initial features. Later many features are added here. Out of this, most important these two things: independent platform and portability. So because of these features only Java got lot of popularity. Independent platform and portability. Because of first two features, Java got this much of popularity. Yes, let us see. So Java is an independent platform. Yes, about first one. Let us say about this one here. Yes, Java is independent platform. Java is an independent platform. What does it mean? Yes, what does it mean? What does it mean? Okay, Java is an independent platform. What does it mean? So first of all, what is platform? Platform means what? So platform means. See, so previous session, we have discussed about OS, right? In previous session, we have discussed about operating system. See about operating system. Yes, OS is a platform where we can run all the application software, right? So OS acting like a platform. OS acting like a platform. See this. Here, this is your computer. In your computer, there is a hardware, right? On top of hardware, there is a OS. Okay, here computer, there is a hardware. On top of hardware, there is a OS, right? Okay. See, these two layers, hardware and OS, these two layers is a platform. So these two layers is a platform. Hardware layer and OS layer. So these two layers is a platform. So platform means it's a combination of hardware and OS. Platform means a combination of hardware and OS, right? So these two layers is a platform. So a platform means yes, it's a combination. Yes, it's a combination. Yes, it's a combination of hardware, hardware and operating system. Hardware and operating system. So platform means it's a combination of hardware and operating system. Yes, operating system, right? Yes, platform. So here platform means platform means it's a combination of hardware. Yes, hardware and operating system. It's a combination of hardware and operating system. Clear? So these two layers is a platform. So here, so platform means it's a combination of hardware and operating system. Okay, right? Now Java is an independent platform. What does it mean here? Java is an independent platform. What does it mean? Okay, what does it mean? Okay, that means here. So Java program can run. Java program can run on any hardware independent. Okay, any hardware and any OS. Any hardware and any OS. That's the meaning here. So Java is independent platform. What does it mean here? So for this answer here, yes, Java program can run on any hardware. Independent platform means Java program can run on any hardware and any ways. Any hardware and any ways. Okay. Yes, any hardware, anyway. Yes, okay, fine. Now question is here. Yes, how Java made us independent platform? Yes, immediately this question may be asking this most important question. It's the interview question. 100% interview question this is. Okay, now how Java made us independent platform? That is immediate question. How it is independent platform? Independent platform. Immediately question here. Okay. How Java made us independent platform? Okay. How Java made us independent platform? Yes, to answer this question, yes, you must have the idea of exe file and dot class files. Yes, if you know about this exe files and dot class files, we can answer this question. Yes, you must have the exe file knowledge, dot exe, executable file, dot exe, dot exe, that exe file knowledge and dot class file knowledge. You must have these two knowledge. So once you have the exe file dot class file, yes, you can answer this question. First, let us start with exe file. Exe file. So what is exe file here? See, exe file means executable file. Executable file. Exe file is a binary code file. Exe file is a binary code file. Binary code file, and it is a system understandable language. System understandable language. System understandable language. It's a system understandable language. It's a system understandable language. Okay. So exe file. Exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. System means, yes, your computer. Processor understandable language. It's a processor understandable language. Okay, fine. Okay, fine. Exe file is a binary code file and it's a system understandable language. Okay, fine. Here, question is here. Some question for you guys. Suppose, for example, question is here, exe file. Question is here that executable for some exe file. Exe file prepared or generated. Exe file prepared on Windows OS. exe file prepared on Windows OS. Okay. So question is here, exe file prepared on Windows OS. Can I run on Linux OS? Yes. Anyone, can you answer this question? Of course, I'll explain clearly. Just I'm asking your idea. Question is exe file prepared on Windows OS. Exe file prepared on Windows OS. Can I run on Linux OS or any other ways? Yes, exe file prepared on Windows OS. Can I run on Linux OS?
No.
Yeah, come on. Santosh is saying something. No.
No.
No. Next others. Next others. Anyone? Yes. Answer is no. Answer is no. What's the reason? Let me explain reason. So reason, exe file is a OS dependent. Yeah, reason exe file is a platform dependent or OS dependent, anyone can say. Exe file is a OS dependent. OS dependent. See, exe file is a OS. See, exe file prepared in Windows OS. Can I run a Linux OS? Answer is no. Reason, exe file is an OS dependent. Exe file is an OS dependent. Yes, immediately question, why exe file? Why exe file OS dependent? Yes, interesting point. Why exe file is OS dependent? So why exe file is OS dependent? Yeah, let us answer this question here. So why exe file OS dependent? Let me answer this question. Yes, to answer this question, first of all, yes, you must have the exe file knowledge. So what is exact exe file? What does it contain? Yes, you must have that exe file knowledge. Yes, let us see about exe file. No topic about exe file. See about your exe file. About exe file. Okay, suppose for example, let us take C program exe file. Yes, practically I'll show this C program exe file. I'll show now here. So C program exe file prepared on Windows OS. Then it contains what? Then it contains yes, let us see. It contains what? C program exe file prepared on Windows OS. Then it contains what? Let us see. Now let me show C program. One second, let me close this Eclipse. C program. Here, this is a C program here. Suppose C. Yeah. C program. Here it is a C program. So this is C program. C program. So test.cpp. CPP means C++. C language C++. Both are same. Both are exe based. So here C++ compiler using for the C program. Here program is actually C program. C program. Okay. C program. Now here name of the program file is test.cpp. Test.cpp. Now behind of this one, C drive, TC. TC means turbo C. So here installed. Turbo C installed here. Next bin folder, open bin folder. Here you can see test file. So here test. So yesterday we had discussed something about exe file. I'm repeating the topic once again. See, I'm deleting all the related files. Test.cpp. So this is your program. Test.cpp. So this is your program, right? So this is your program. Okay. Fine. So test.cpp file, yes, test.cpp. Now I'm compiling this program. Compile option. Yes, compile. There is a compile option. Enter key. So compiled. And compilation, see at the end, just now generated .obj file. Test.obj file 28/3, just now, 28th day, 28th March, 1945. Just now that obj file generated. Okay. Yes, obj file generated. So refresh. See here you can see test.cpp for this test.obj file generated. So what is this obj? Obj means object file. So what is this object file? What is this object file? Here, what happens is C compiler checking all the errors from top to bottom. C compile, success, no errors, right? Success, no errors. So checking all the errors from top to bottom. If no errors, simply compare converting this your C program into binary format. Only your C program converted binary formats. So the C program. So from wide main, from this onwards, converts into binary format right to this object file. So test.obj. This object file contains what? Binary code for our program. Binary code, machine language for our program. Next. Apart from that, see these are predefined library. stdio.h and conio.h. So these are predefined library. This predefined library also contains its own binary format. Predefined means already developed, already available that libraries. Because that is with C software. So these files, this library also having its own binary code. Okay. So after compiling your C program, yes, your code converts into binary format and generating as test.obj. So this is binary code for your C program. So this is test.obj file, binary code for your C program. Okay, fine. Next year, stdio.h file. convoluted. These are predefined header files. These header files is also having its own binary codes. Just 1 second. Okay. Yeah. So this is your C program binary code. Next, these header files also having its own binary code. Okay, fine. Now here after compilation here, so creating exe file. That exe file. How that exe file creating? So when you try to run this program, run it. When I try to run this program, yes, run it. Yes, first exe file creates. See, at the bottom you can see exe file it. That exe file created. That exe file created. Exe file. So for this test.cpp, now this is test.exe file, right? Now this exe file executing now here. Exe file executing now. Enter first number 10, enter second number 20 is getting the result, right? So this exe file contains what? Now this exe file. How that exe file generating here? Yes, simply C compiler. C compiler taking binary code for our program means test.obj. So binary code for C program. Okay. Yes, the C compiler taking binary codes. Binary codes. Binary codes. So binary code for our C program. Binary code for C program. Binary code for C program plus next binary codes. Binary code for C library. Binary code for C library. Binary code for C library plus. Apart from this, so binary code for C program means the test.obj file. This one. Next, binary code for C library means this is stdio data, conjugate data. These binary codes. Plus, apart from that, one more thing here. See, here this is a OS, right? Instead of OS, this is a library. Library. This library also is having binary code. This library. So purpose of this OS library is to communicate with hardware. Okay. See, these programs, all these C programs, C++, Java, all the programs, first of all, linking with OS library, using OS library, communicating with the hardware components. So every program has to link with OS library. So linking with OS library. So this library also having its own binary code. That OS library is having its own binary codes. OS library having its own binary codes. So this binary code, this library, this binary is also linking with exe file creating here. So next binary codes. Binary code for yes, now it's a Windows OS, right? Windows OS library. Binary code for Windows OS library. Right? Yes. C program exe file prepared on Windows OS, then it contains binary code for your C program, binary code for C library, next binary code for Windows OS library by linking all three binaries here. Okay, by linking all three binaries here, creating exe, it creates exe file. That's it. So that is about exe file. So exe file contains binary of your program. Yes, binaries of your C library, binaries of OS library. By linking all of this, it generates exe file. So finally here exe file contains binary code for C program, binary code for C library, binary code for OS library. Yes, let us take one more example here. One more example. Yes, let us take C++ program. C++ program exe file. Suppose C++ program exe file prepared on. Okay, 1 second. Same C program. C program exe file. C program exe file prepared on Linux base, not OS changing. Linux base. Now OS changing. Yes, C program exe file prepared on Linux base, then it contains binary code for C program. Next, binary code for C C library. Next binary code for what here? Linux based library. Now library Linux based, that library changed. Linux based library. Linux based library. So this is another example, right? Yes, let us take one more example here. One more. Now let us take C++ example. For example here, C++. C++ exe file prepared on Windows OS. Windows OS. Windows OS, then it contains binary code for C++ program, binary code for C++ library, something like iOS team data etc. file like that. C++ library and binary code for yes Windows OS library. Windows OS library. Windows OS library. Suppose one more example. C program exe file prepared on Mac OS. One more OS Mac OS. Then it contains binary code for C program, binary code for C library, binary code for Mac library, right? Mac library. So what is happening here? So all the four cases. So first example, next example, all the four cases here. So which is common point here? OS library. So OS library, yes, all these four cases. What is happening here? OS library coming, right? OS library coming. Okay. So every yes here. So here yes. So every exe file, yes, exe file always linking with OS library. Yes, that may be generating on Windows OS or Linux OS or Mac OS, whatever it is. So exe file always links with OS library. Yes, exe file, yes, always. Exe file, yes, always, yes, linking with OS library. Linking with OS library. Linking with OS library. OS library. So OS library becomes part of exe file. So exe file contains OS library. So exe file contains yes exe file. Exe file contains OS library. OS library. Exe file contains OS library. Okay, fine. Now suppose this is a test.exe file. Test.exe file prepared on Windows OS. Prepared on Windows OS. Test.exe file prepared on Windows. For example, test.exe file prepared on yes Windows OS. Then yes it links. Then it links with Windows OS library. Links with Windows OS library. Windows OS library. Library, great. So you get now test.exe file. The test.exe file with Win library. Win library. Yes, working on different platforms. Let us see. So test.exe file with Win library. Yes, with Windows library. See, test.exe file prepared on Windows OS. Then it links with Windows OS library. So the test.exe file with Win library working on different platforms. Working on different platforms. Let us see how that is working on different platforms. Different platforms. Let us see. First, let us take the Windows platform. Windows platform. Yes, your computer. Suppose hardware. Yes, hardware. Hardware. Yes, your computer hardware. On top of hardware. Next OS. Yes, Windows OS. Windows. So first I'm taking Windows platform. Windows OS. So Windows with Win library. Windows with Win library. Right? Win library. Windows OS with Win library. So if there is a hardware. Yes, on top of hardware. That OS running, right? Windows OS running. Okay, Win library. So Windows OS with Win library. Now on top of it, now your exe file. So exe now on top, yes, hardware on top of it, Windows OS on top of Windows OS. Now your program running. So test.exe file. Okay. So when I try to see test.exe file with Win library working on different platforms. Working on different platforms. Okay. So working on different platforms. So test.exe file. So when I try to run test.exe file, what happens here? Now it makes a call to simply it makes a call to Win library. Just simply call to Win library. Okay. Since test.exe file, linked with Win library, since test.exe file linked with Win library, yes, it will try to call to Windows library, that Win library, yes, it's available. Okay, same environment, it's available here. Okay, so simply to try to call to Win library, yes, available here. So simply call to Win library, yes, available. Using that library, communicating with hardware components, so successfully executing. So since test.exe file linked with Windows OS library, it will try to call Windows OS library. Yes, available. Since available, using that library, communicating with the hardware, so successfully program finishing, successfully executing. Now let us take another platform, Linux platform. Linux platform. Let us take Linux platform. Same test.exe file. If you try to run Linux, what happens? Let me explain clearly. Now Linux platform. Linux platform. Yes, Linux base. Linux base with yes, Linux library. Okay. So here Windows base with Win library. So when test.exe file running on Windows base here, it will try to call to Windows base library. So same that Win library here is available. So using that library, communicating with the hardware components, so successfully finishing. Now same test.exe file, if I'm running a Linux base, what happens here? Linux base, what happens here? Note this test.exe file, since linked with Win library, already linked at the time of creation of exe file itself, linked with Windows OS library, that link is fixed. So linked already, that link is fixed. Since link is fixed here, always it will try to call Windows library. So wherever you executing, always it will try to call Windows OS library because that link is fixed. That link is fixed. Now test.exe file, simply, yes. So this is executing a Linux OS. When you try to execute a Linux OS here, even on Linux OS also it will try to call, yes, it will try to call Windows OS library, but it is not available. Library is not matching. So that is not available. So it will try to call Windows OS library and Linux environment, right? But not available. That library is not matching. Simply call fails. That call fails. So test.exe file, since test.exe file already linked with Windows OS library, it will try to call to Windows OS library, but that library is not available. Means environment is not matching. Simply it fails. Simply it fails. Okay. Let us take one more platform. Another platform. So Mac platform. Mac OS. So Mac OS. Now Mac OS with Mac library. Mac OS with Mac library. Now here also see test.exe file already linked with Windows OS library. That link is fixed. So when you same exe file, when you try to run on Mac OS here, yes, it will try to call to Windows OS library on Mac system, but not available. Simply call fails. Okay. So you can since exe file linked with Windows OS library, it will try to call Windows OS library on Mac environment, but not available. Library is not matching. Simply it fails. That exe fails on Mac OS. That exe fails on Linux base. That working on only Windows base, right? So that's the reason exe base OS dependent. Okay, that link. So once exe file at the time of creation of exe file itself, that library linking with yes exe file, yes links with yes exe file, right? So since OS library linked with exe file, that link is a fixed. Means statically linking. Static means fixed. Okay. So since exe file statically linked with OS library, it's a platform dependent. Okay. Yes. Since exe file statically linked. Statically means fixed. Static means fixed. So that link is fixed, that never changes. Link is always fixed, that never changes. Since exe file statically linked with OS library, OS library, yes, OS library, yes, it's a yes. Since exe file statically linked with OS library, yes, it's a platform dependent or OS dependent. It's a platform dependent. It's a platform dependent. So that's the reason why exe file is OS dependent. Reason is this. Okay, reason exe file always linking with OS library is a statically linking with OS library. Since exe file statically linked with OS library, it's a platform dependent, right? Yes. So this is about exe file. Okay. Yes. Now let us answer our question here. Question. So why exe file is OS dependent? Reason. Since exe file statically linked with OS library, it's a platform dependent or OS dependent. Anyone you can say OS dependent. OS dependent. That's it. Now let us come to Java. Actual topic. So exe file is okay. How Java made us independent platform? How Java? Yes. How Java made us independent platform? Now we should answer this question. For this purpose, now we should discuss about dot class file. Now topic is about dot class file. Topic is about dot class file. Yes, about Java dot class file. Java dot class. Okay. Yes, about dot class. So you get dot class file. Dot class file. Dot class file is a binary code file. It's a byte code file, not a binary byte code file. It's a byte code file, and it's a JVM understandable language. Binary code is a system understandable. Binary code is a system understandable, but byte code is a JVM understandable language. So dot class file is a byte code file, and it's a JVM, Java virtual machine, JVM understandable language. JVM is a JVM understandable language. Okay, fine. Now, yes, now about dot class file. For example, here, Java dot class file. Yes, one second. Let us take same example, like C programming. Same example. Let us take this example. This example. Yes, dot class file. For example, C program. This is now it's a Java program. Yes, dot not ex. Java don't have exe, so it's a dot class file. Java dot class file prepared in this ways, then it contains what? Can you guess it here as per this? So Java program dot class file prepared in Windows ways, then it contains what? Binary code. No, it's a byte code. Byte code for Java program.
Java program.
Byte code for Java program. Next what? Byte code for
Byte code for
Java library.
Java library. Byte code for Java library. And next what?
byte
for
code
Java
for
Windows.
Windows.
Byte
OS.
code in this ways, huh?
Mm.
So OS don't have the byte code. OS is always in binary format only. OS
Okay.
is not related to Java, right? Java different, OS is different. OS is not related to Java. OS always contains binary code only. The OS library is always in binary format only. So binary code for OS library. OS library is always in binary format. Always in binary format. Okay, right? Yes. No, this part don't have. No. Yes. So Java program dot class file prepared in this way, then it contains byte code for Java program and byte code for Java library. That's it here. Okay. Yes. OS library never linking with dot class file. Okay. See byte code for Java program, next byte code for Java library. See Java library also developed in Java. Java library also developed in Java. See C language library in C language only. Python library in Python only here. C++ library in C++ only here. Java library in Java only here. Right? Yes. So bytecode for your Java program. Next bytecode for Java library. Java library also Java. That means so all this bytecode for your Java program, bytecode for Java library. The Java library also Java program byte format. Java library also Java program byte format. Means it's a pure byte code format here, pure Java program. So dot class file is a pure Java program, pure Java program. Yes, in bytecode format, bytecode format, right? Yes, dot class file. So you can dot class file is pure Java program in bytecode format. So dot class file is a pure Java program bytecode format. Okay, right? Yes, you don't have any OS library. You don't have. Yes, you don't have. Yes, you don't have. Yes, any OS library. You don't have any OS library. You don't have any OS library. Okay, dot class file. Yes, you don't have. You don't have any OS library. Yes, it is free from OS library. Dot class file. It is free from. Yes, it is free from OS library. It's free from OS library. It's a free from OS library. It's a free from OS library. It's a free from OS library. Okay. So you can dot class file is a pure Java program. Dot class file is a pure Java program bytecode format. Yes, you don't have OS library. Means it is now free from. It is free from OS library. It is free from OS library. Okay, fine. Suppose, for example, here tested dot class. Let us take some tested dot class file. Suppose tested dot class file prepared. Yes, prepared on anyways. Okay, tested dot class file prepared on anyways here. You don't have any library. Okay, it should not. Yes, it don't have any OS library here. Tested dot class file. Yes, may be prepared. Okay, may be prepared on anyways. Tested dot class file may be prepared on anyways. You don't have any library here. You don't have. Yes, you don't have. Yes, you don't have any library. You don't have. Yes, you don't have any OS library. Don't have. Yes, any OS library. Right? You don't have any OS library. No tested dot class file working on different platforms. Let us see. Tested dot class file. Yes, working on different platforms. Yes, how that will be working on different platforms? Working on different platforms. Okay. Yes, like C program exe file. Let us take different platforms here. First, Windows platform. Yes, let us take Windows platform. So working on different first Windows platform. Tested dot class file on Windows platform. See hardware, Windows OS with Win library. Okay, now tested dot class file. Not tested dot class, right? Not tested dot class. So tested dot class file working on different platforms. So when you try to run tested dot class file, what happens here? So you can will it run directly or not? See, to run any program, this program compulsory should link with Windows OS library. It should be linked with OS, otherwise cannot run here. Any program has to link with OS library, otherwise cannot run it here. Okay. See previous session. C program, C++, Java, all the programs. Every program has to link with OS library to communicate with hardware components. Without linking with OS library, never communicating the hardware. It has to link compulsory. That link should be there compulsory here. Okay. See, every program has to link with OS library before going to run. It has to link with OS library. It's a rule. It's compulsory. Otherwise, it cannot communicate with hardware, right? So OS library is the way. To communicate with hardware components. So in order to communicate with the hardware here, this program has to link with OS library. Suppose if it is C program exe file at the time of At the time of creation of, yeah, 1 second. Hello. Yeah. Tomorrow morning 11, okay, sir. Okay, sir. Yeah, thank you, sir. Thank you, sir. సార్ నేను ఆఫీస్లో ఉన్నాను, రాగానే షేర్ చేస్తారండి. యా మార్నింగ్ 8 కల్లా మీకు షేర్ చేస్తానండి. రైట్ సార్. యా సో every program has to link with OS library to communicate with the hardware components, otherwise cannot. Now come to this Java. Suppose C program. In case of C program, at the time of creation of exe file itself linking, right? All are linked. At the time of creation of exe file itself linked. Okay, so communicating with Windows OS, then executing. Okay, but when come to dot class file here, dot class file is not linked. Okay, so when I try to execute the dot class, no, it won't run. It has to link. Okay, so now this tested dot class file free from OS library. So tested dot class file is free from OS library. Don't have any link, but it has to link. Who will link it? Okay, so tested dot class file don't have any OS library. It's not linked with any OS library, but it has to link, otherwise cannot execute. Okay, so to link this tested dot class file, to link it here between tested dot class file and Windows OS, one more layer will come to picture. So between tested dot class file, Windows OS library, so one more layer come to picture. What is that layer? Anyone can you guess it? Anyone can you guess it? Between tested dot class file, Windows OS, one more layer will come to picture. What is that layer? Yes, linking purpose. Tested dot class file linking with Windows OS library. In order to link, so to link with OS library, between this one more layer, that layer is a
virtual machine.
Yeah, virtual with JVM. Now, JVM. So JVM will come to picture. That JVM will come to picture. JVM. So Windows OS, right? Windows OS, here this JVM. Now inside the Windows OS, this JVM. Windows OS contains one JVM. Windows OS JVM. So the JVM taking tested dot class file. JVM taking tested dot class file links with Windows OS library. Once linking here, communicates with the hardware, then successfully executing. Fine. Now let us take another platform. Windows platform, okay. Now let us take Linux platform. Linux platform. Hardware. Yes, Linux base with Linux library. Right? Now here also same JVM here. Yes, now Linux base. Now inside the Linux base, there is Linux JVM. See, Windows OS has Windows JVM here. Linux has Linux JVM. So when tested dot class for running a Linux base here, now Linux JVM taking test dot class for links with Linux base library. Of linking execution starts communicates with the hardware components. Okay, now let us take one more platform here. One more platform. Suppose Mac. Test dot class file. Mac voice. Mac library. So on Mac OS of this JVM, that Mac JVM. So Mac JVM taking test dot class for Mac linked with Mac library. So what is happening every time of changing ways? Get that link is changing, right? Yes, if dot class for running on Windows OS, JVM linking test class file with Windows OS library. Same dot class for when you're running a Linux OS, then JVM linking with Linux library. Okay, if it is running on Mac OS, then linking with Mac library. Suppose if running on Linux OS, links with Linux library. So every time of changing ways. So what is happening here? So every time of changing weights, every time of changing weights. So every time of changing weights. See every time of changing weights. Okay, link changing, right? Every time of changing weights, every time of changing weights. Okay, link changing, right? Link changing. Okay, so every time of changing that ways, that link is changing, right? Every time of changing ways can ways link, ways that link change. Every time of changing ways, link is changing by the JVM, right? By the JVM, right? By the JVM. Okay, right? Yes, since dot class file links with ways library for every time of changing ways, it's a ways independent. That's the reason platform independent here. Yes, since dot class file. Yes, since dot class file. Since dot class file. See, every time of changing ways at runtime, every time of changing ways. So runtime, every time of changing ways, link is changing by the JVM, right? So yes, runtime linking changing here. That link is changing. That is a dynamic process. Link fix means that is static. Link fix means static. In case of exe, there is static linking. But when come to dot class, that link is changing every time. Runtime that link is changing. That is dynamic process. Dynamically. So since dot class file, dynamically, dynamical linking with voice library, voice library. Yes, it's a independent platform. Yes, it is an independent. It's an independent platform. It's an independent platform. That's it, right? So here, why dot class file is independent platform? Since dot class file dynamically linking with voice library. Yes, it's an independent platform. That's it here. Okay. Yes. Now, your question: how Java made us independent platform? Yes. How Java made us independent? How Java made us independent platform? For this answer, yes. Dot class file dynamically linking with voice library. By the JVM, it's an independent platform. Since dot class file dynamically linking with voice library by the JVM, it's an independent platform. So every time of changing voice, that link changes. Okay, every time of changing voice, that link changes. If dot class, suppose, see, if dot class file running on Windows voice, links to Windows voice library. Same dot class file if it's running a Linux voice, links to Linux library. Suppose same dot class file if it's on Mac voice, links to Mac library. Same dot class file if it is on Solaris voice, linking with Solaris voice here. Okay, so JVM takes care of linking here. So Windows JVM, yes, links with Windows voice library. Now Linux JVM, yes, linking tested dot class file Linux voice library. Okay, right? Yes, next Mac voice JVM taking dot test links with Mac library. So every time of changing voice, that link changes. That is called dynamic linking. Changing link, dynamic. Changing link means dynamically. Link is fixed means static. Yes, in case of exe file, that link is fixed, never changes. That is statical linking. Exe file is a statical linking. Since exe file statical linking, since exe file, yes, since exe file statical linking with voice library is a platform dependent. It's a platform dependent. It's a platform dependent, right? Yes, since exe file statical linking with voice library, it's a platform dependent. Next, when come to dot class file, since dot class file dynamic linking, yes, dynamic linking, yes, it's a independent platform. Independent platform. See scenario. So wherever statically linking, statical linking, that is platform dependent, platform dependent. Okay. Yes, all exe case, all exe files, C program exe file, C++ exe file, .NET exe file. So wherever that exe concept is there, that is statical linking. Wherever the exe file concept is, that is statically linking, it's a platform dependent. Okay, right? Yes, dynamically linking. Suppose if it is dynamically linking. Okay, if it is dynamically linking, that is yes, independent of platform. Independent of platform. That is independent of platform. Right? Yes, since dynamically linking, that is independent of platform. Okay. Yes. So all exe files statically linking. Okay. See all exe files. Maybe C program exe files. Okay. Yes, C program exe files or C++ exe file, .exe file, all exe files statically linking. All exe files statically linking, right? Yes. When come to Java, Java.plus file, Java.plus file. Next, one more thing. See, Python is also independent of platform. Yes, even Python also independent of Python. So Python also independent of platform. Python. One second. So Python. See, not only Java.plus file, even Python script also independent of platform. Python scripting also independent of platform portability. Java and Python both are independent of platform and portability. That portability next we'll discuss. Now independent of platform. Java, Python both are independent of platform. Reason Java.class file and Python script file, both dynamically linking with OS library. Okay, so get Java.class file and Python script file, both are dynamically linking with OS library. So these are independent of platform. So these two are independent of platform. Independent of platform, right? Independent of platform. Okay, that's okay, fine. Yes. So here statically linking with, that is platform dependent, dynamically linking is independent of platform. That's okay, fine. Now here doubt too. Here may be some doubt here. Now here, see, simply I'm saying that Windows JVM taking test.class for linking with Windows OS library. Next, Linux JVM taking test.class for links with Linux OS library. Next, Mac JVM taking .class for links with Mac library. Now question is, JVM, is it part of OS? Yes, you guys, can you guess it? JVM, is it part of OS? JVM, is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. JVM is not a part of OS. Okay. JVM is not a part of OS. So JVM, yes, from JDK software. JVM from the JDK software. JVM from the JDK software. JVM is not a part of OS. JVM is not a part of OS. So JVM from the JDK software. Then how to get the JVM here? Yes, to get JVM, yes, we should install yes, JDK on your OS. That's it here. So when you want to get the JVM, yes, JVM is not a part of OS. JVM from the JDK software. To get JVM, we should install JDK on your OS. Otherwise cannot, right? Yes. So here when you want to run .class file, first of all you have to install your JDK. So once JDK install, getting JVM automatically. So once JDK install, getting JVM automatically. Okay. So on Windows, installing JDK. Next on Linux, installing JDK. Yes, on Mac OS you have to install JDK. So once JDK software installed, you can get the JVM. That's okay, fine. Okay. So on your OS, getting JVM. So once install JDK, you can get the JVM. That's okay, fine here. Next, one more interesting point here. one more interesting point. Java dot class file. Java dot class file, yes, is an independent platform. Independent platform. Java dot class file is an independent platform. Right? Java dot class file is an independent platform, but JVM is a OS dependent or platform dependent. Okay. So here interesting point here. Java program is independent of platform, but actual JVM is a OS dependent. JVM is a OS dependent. So JVM is a OS dependent. JVM is a OS dependent. So JVM is a OS dependent. So why JVM is a OS dependent here? See, Java dot class file is a independent, but JVM is an OS dependent. Reason. So why JVM is a OS dependent? Reason. Yes, JVM is a JVM developed in C++. JVM developed in C++. Okay. So when you're running Java program, the behind of Java program, JVM working. So behind of JVM, C++ program running. Okay. Yes, behind of every Java program, JVM will run. Behind of JVM, C++ program will run finally. Yes, that point we'll discuss practically in Java programming. In Java programming, when Java program executed, behind of Java program, how JVM working, is behind of JVM, how C++ code is working, that practically I'll show. In Java programming, I'll show that. Okay. Yes, JVM developed in C++. Okay. Since developed in C++. Developed in C++. Yes, it's an exe file. It's an exe file. Right? Yes, since developed in C++, it's a C++. If you developed in C++, exe file, right? It's exe file. I hope you understand, right? Exe file, C++. If it is C++ code, definitely it's exe file, no doubt. C programming exe file, C++ exe file. So the exe, it's exe file. It's exe file, right? So it has JVM developed in C++. So since developed in C++, it's an exe file. Okay, JVM is a C++ exe file. Simply, so JVM is a C++ exe file. C++ exe file. That's it here. That's the reason JVM is a platform dependent. Yes, here Sun Microsystems. Sun Microsystems have developed. Sun Microsystems have developed. Yes, JVM. Yes, Sun Microsystems have developed JVM for every ways the market. Every way is the market, right? Every way is the market. Because the Java program has to run on every ways. For this purpose, Sun Microsystems have developed JVM for every ways. JVM for Windows ways, JVM for Linux ways, JVM for Unix ways, JVM for Mac ways, so JVM for Solaris. Like that, for every ways they have developed. So that JVM, that voice related JVM is responsible to run our dot class file. Okay, so voice related JVM. So you get JVM is responsible. So you get JVM is responsible. JVM is responsible to run dot class file. Dot class file, that's here. So JVM, because of JVM, Java is independent platform. Okay, JVM is responsible. JVM is responsible to run dot class file simply. I think it's clear. Okay, right? Yes, now here, one more point here, one more interesting point. Suppose JDK, installing JDK. So once JDK installed, yes, we can get JVM, right? Now question is, same JDK can I install on all operations? Same JDK can I install on every ways here? See, let us answer that question. Yes, if it is Windows ways, Windows JVM. Linux ways, Linux, so JVM is different, right? JVM is not same. JVM is different for different operations. Windows JVM is different, Linux JVM different. Okay, next Mac JVM different. So different JVMs developed in for different operations. Okay, so Windows JVM can understand Windows environment. Windows JVM yes, Windows JVM is having knowledge of Windows OS library, so it can link with Windows OS. Next, Linux JVM is having knowledge of Linux library, so it can link with Linux library, right? So here Mac JVM is having knowledge of Mac library. So, but knowledge purpose, for that purpose, separate JVMs developed here. Windows JVM is having knowledge of Windows environment. Linux JVM is having knowledge of Linux environment. Mac JVM is having knowledge of Mac library. That's it here. So for yes, for knowledge purpose, that idea purpose, different JVMs developed here. Windows JVM different, Linux JVM different, Mac JVM different here. Different operations, different JVMs developed. Okay, right? Okay, fine. Now, so JDK installing and Windows OS. To install JDK and Windows OS, the JDK must have JVM, Windows JVM. So here JDK installing and Windows OS, that JDK must have Windows JVM. Now suppose JDK installing Linux OS, that JDK must have Linux JVM, right? Okay. Yes, next Mac. So JDK installing and Mac, for this that JDK must have Mac JVM, right? That means JDK content changing. When OS changing, JDK content also changing. So the JVM changing, right? Okay. So same JDK you cannot install on different operations because the JVM is different. Okay. Yes, if you want to install JDK and Windows OS, yes, Windows with the JDK must have Windows JVM. Yes, on Linux base, that JDK must have Linux JVM. So since JVM changes, JDK also changes. So JDK also OS dependent. Same JDK cannot be installed on different operations here, right? So same JDK, yes, same JDK cannot be yes installed. Cannot be installed. Yes, cannot be installed. Installed on different operations. On different operations, right? Different operations. Same JDK cannot be here. Okay. So for different operations, different JDK required. JDK is different. JDK is not same here. Same JDK cannot be installed on different operations. Let me show that. Yes, that Oracle site. Yes, download JDK 1.8. See this. From Oracle site. Downloading. See this. So this is JDK. Here it is JDK. Here this is JDK, right? See, Linux. So Linux JDK. In Linux also we have different flavors. Different flavors of Linux base, like Ubuntu Linux base, next CentOS, like that. There are different Linux flavors are there. So on Linux also that JDK changes. Next see that Mac JDK. So this is Mac JDK. Next Solaris. So Solaris JDK. Next Windows JDK. Okay. So Windows JDK, Linux JDK, Solaris JDK, Mac JDK, right? So for different operations, different JDKs available. Here download separate JDK here, not same. Suppose your system is Windows OS, then download this one. This last one you have to download it. Okay. Yes, suppose your system is Linux system here, then tar file, tar.gz. So the 64-bit tar.gz file. Okay. Suppose if it is Red Hat Linux, RPM file you have downloaded. This is for Red Hat Linux. RPM, Red Hat Pack Manager. So this is for Red Hat Linux base. This is for Ubuntu and other Linux systems. .tmg file. This is for Mac base. Next, these are for Solaris operations. Next, this is for Windows base. So JDK, different JDK for different operations. See, you guys need not to download JDK. I will provide you. Now, which one OS you want? Just you tell me, that I will provide you. Yes, my office software I will provide you. Without any issues, you can run it here. Suppose if you're downloading your own softwares, maybe getting version compatibility issues, version problems, you guys don't download, I will provide you software. Okay, I will provide you JDK and Eclipse. JDK and Eclipse, both I will provide you. Don't worry about it. Okay, so these are reason independent platform. Okay, independent platform. So why Java is independent platform? Is a reason. We end of this much of story. Okay, so exe file. So why exe file is why exe file is OS dependent? Since exe file statically linking with OS library is a platform dependent or OS dependent. Okay, yes. How dot class file made us independent platform? Since dot class file dynamically linking with OS library by the JVM, it's a independent platform. Independent platform. So scenario wherever statically linking, it's a platform dependent. Statically linking is a platform dependent. Dynamic linking is a independent platform. Independent platform. I hope you understand, guys, right? Everyone,
Yes.
it's clear, right?
Yes.
Yes. So that is about execfile dot class file. Okay. One second. So this kind of information even Google also will not provide. It's my challenge. Just you ask in Google. Difference between execfile dot class file. Just you ask in Google. No information. Yes. Let me explain. Difference between execfile dot class file. The differences. See, execfile dot class file differences. I have prepared very clearly. See, execfile dot class file differences. Exe file, it's a binary code file. Dot class is a byte code file. So exe file is a byte. Yes, 1 second. 1 second. Next session, students are bringing me 8:45 session. Just 1 minute. Let me answer them. Yeah, okay. Exe file and dot class file. So what is exe file? It's a binary code file, right? Dot class is a byte code file. Okay. Yes, exe file is a, yes, okay. Otherwise, let me explain. Better. Instead of showing that, better type. Yes, exe file. Yes, about exe file and dot class file. Exe file and dot class file. So first point, exe file. See, exe file is a binary code. First difference, exe file is a binary code file. What is dot class file? Yes, it's a byte code file. It's a byte code file. It's a byte code file. It's a byte code file, right? Okay. Next, exe. Yes, it is a system understandable language. It's a system understandable. It's a system understandable. It's a system understandable. It's a system understandable language. It's a system understandable language. Okay. Dot class. It is a JVM understandable language. It's a JVM understandable. JVM understandable language. JVM understandable. Yes, understandable language. JVM understandable language. Right. Next important difference. Exe file. Exe file contains OS library. Exe file contains OS library. Exe file contains OS library. OS library. Right? Yes, dot class file. Dot class file don't have any OS library. Don't have any OS library. OS library. Dot class file don't have any OS library. Here's some doubt here. Exe file contains OS library. Yes. How I got this knowledge? Where I got this knowledge? Here. See, simply Java developer. With Java developers don't have any exe file knowledge, I'm sure. Maybe 20 years or 30 years, whatever the experience. Java developer never have the exe file knowledge. So then how I know this one here? Reason. First, my 4 years of experience embedded C language. I worked on embedded C. So because of that, I have this knowledge here. exe file knowledge in embedded C. So embedded C, so exe file. So that exe file in embedded C, everything is exe file on here. That exe file linking with OS library. In embedded C programming, you can see practically. Yes, in embedded C, the linkers concepts are linkers. That linkers will take OS library linking with exe file. So what happens in embedded C programming development? We will link as a C programmer, will take OS library linking with exe file. So embedded C developer, the C programmer will have exe file as compulsory because manually they will link it here. Okay, that embedded C developer, manually they will link C program with OS library. So because of that, I have that knowledge. My first 4 years, embedded C and Linux base I worked. Okay, yes, around 2000 year started Java career. Before 2000, my career, first 3 to 4 years of career, embedded C. Because of that reason, I have this knowledge. Okay, right? Simply Java developer means Java developer don't have this much of knowledge, I'm sure. Java developer, Java trainers don't have this knowledge. Okay, because of my embedded C knowledge. I have a lot of knowledge, not only Java. I work on embedded C. Next, Java, Hadoop, big data, on different databases and Python. Yes, I have multiple skills. Because of multiple skills, only I have this much of knowledge. Okay, my knowledge is more than the Google, I'm sure. Okay, some cases even Google also will not provide that kind of information. Okay, yes, that level I have the knowledge. Yes, search in Google. Yes, how Java made us independent platform? Yes, simple 1 or 2 lines answer. That will not explain this much of thing here. Even Google also will not provide this much of information. That is my level of knowledge. Okay, now let us continue. So exe file dot class file differences. Exe file dot class file. See, exe file contains OS library dot class file don't have OS library. Okay, right? Yes. Here exe file statically, yes, statically linking with OS library, OS library. Yes, next here dot class file dynamically, yes, dynamically linking with OS library, dynamically linking with OS library, So static linking and dynamic linking. Okay. So yes, exe file contains OS library, dot class file don't have any OS library. So exe file, static linking, dot class file, dynamic linking, right? So since static linking, exe file is a OS dependent. Okay, right? A dot class file, yes, is a independent platform, independent platform, right? Independent platform. Okay. Yes. Next here, one more point here. Yes. exe file. To run the exe file, that software required or not. Suppose, for example, here, C program exe file prepared on Windows base. Okay. Suppose C program, let us say test.exe file prepared on Windows base. First initially here on Windows base, Windows base. Sorry. Windows base. Suppose test.exe file prepared on Windows base. Suppose on Windows system, C software installed. After installing C software, C program developed and exe file prepared. Okay, same exe file now moving into another Windows base. Another Windows base, no issue. So this exe file Okay, placing an another window space. Okay. Yes, here on first Windows system, C software installed, C program developed, and exe file created. After same exe file, just moving on to another Windows space. Now to run this exe file on second system with same Windows. Yes, is it necessary to install C software? C on first Windows system, C software installed, program developed, exe file created, that exe file moving onto another Windows system, same environment. So can I run this exe file without installing C software on the Windows system? Yes, anyone can you answer this?
Yes.
Can I run or not? Yes.
Yes,
So
you can.
yes, Santosh is saying that yes. Next others. Mr. Onkar Chaudhary.
Yes, sir.
Can we run or not? Yes, we can run. Because the software not because already prepared file, exe file already prepared. Binary code format linked with Wise library already prepared. So C programming is not necessary. C software is not necessary. So without that C software, that exe file can run it. Okay, exe file. Yes, to run exe file, that application software means that C software, application software is not necessary. Application software is not necessary. To run exe file, that application software is not necessary. Same thing to run the dot class file. Now same here, same. Now dot class file is independent of platform. Support tested dot class file. Yes, on Windows OS, suppose Windows OS, JDK installed, Java program developed, and generated dot class file. Executed successfully. Same dot class file now moving on to another Windows OS or another Linux anyways, no problem, because that is dynamical linking. Now this dot class file here on first system, JDK installed, Java program developed, and dot class file generated and executed successfully. Same test dot class file. Now running an other system. Same dot class file to run an other system here. Does it require JDK or not?
Yes, it requires specific.
Yes, yes.
Required, sir.
Yes, it's required compulsory. We should install JDK in Windows space, otherwise cannot. Reason why JDK required here?
Because it is JDK will transfer that one to dynamic. Okay, so that's reason JDK.
Not JDK, not
JDK, no, JVM.
JVM, exact JVM. Because JVM has to link this dot class with Windows space library. So on this system, JDK must be available. Sorry, JVM must be available. On this Windows system, JVM must be available. For JVM, JDK should be installed. That's it here. Without JDK, Java dot class cannot run, correct? So to run Java dot class, that OS must have the JDK software, otherwise cannot here. Yes, to run exe file, that software is not necessary. The C software or C++ software is not necessary. Once you get the exe format here, that exe format can run same environment, no issue. But software is not necessary. But here, yes, to run dot class file, yes, JDK should be installed. JDK should be installed. Otherwise cannot. JDK should be installed. To run dot class file, JDK should be installed. Okay, right? Next, one more point. Exe file and dot class file, which can execute fast? Exe file faster, dot class file faster. Exe file faster, dot class file faster. Which can execute faster? Can you guess it?
EXE, sir, maybe.
Yeah,
Why exe file fast?
no, dot class.
See, exe file, binary code file. Okay. Means is a directly system understandable language. Next, one
Yeah.
more thing, exe file already linked with Wise library. exe file already linked and it's a binary code format. So exe file format is system understandable language and already linked with OS library. So everything is ready to run it, right? Exe file is ready to run. So binary format system understandable language plus OS library, everything is available. So readily available. So it's a prepared. So exe file is a prepared file. Exe file is a prepared. Exe file is a prepared file. Prepared file as per the OS, right? As per the OS. As per the OS, right? Dot class. Is it prepared file? No. Dot class contains what bytecode file. That bytecode has to convert into binary format. After converting to binary format, it has to link with OS library. So bytecode to binary format conversion and linking with OS library, that happens at runtime. That happens at run. That is not a prepared file. So dot class file. See dot class file. See dot class file. Dot class file is not a prepared file. Dot class file is not a prepared file. Okay, dot class is not a prepared file. That has to prepare at runtime. Okay, exe file. Since exe file, yes, since exe file is a prepared file, prepared file, yes, it will run directly here. Yes, prepared as per the OS. So prepared as per the OS, suppose if it is Windows OS, linking with Windows OS library, already linked, link is over, directly execution. Again, linking is not necessary. Since exe file is a prepared one, yes, it executes faster. It executes faster. Separate preparation is not necessary. It executes directly, executes faster. Yes, but dot class, since dot class file, yes, this dot class file, yes, will be preparing. Since dot class will be preparing at runtime, preparing at runtime. So before going to execute dot class file, that bytecode has to convert into binary format, linking with OS library. So the dot class file will be preparing at runtime. So exe file is already prepared file, but dot class that will be preparing at runtime. Since dot class file will be preparing at runtime, yes, it runs slowly here. Yes, it runs slowly. Okay, it runs slowly than slower than slower than exe file, but not much slow here, little bit slow. Okay, little bit slow. Yes, even to improve the performance of dot class file in JVM, this JIT compiler added. In JVM, there is a JIT compiler that is to improve the performance of JVM. Yes, we'll discuss. I'll take separate topic and JVM here. Separate class is there and JVM here. That time I'll explain clearly. Okay, so this is differences. Exe file dot class file differences. See the same thing explained prepared in document here. It's a binary code file, byte code file, exe file system understandable, dot class JVM understandable. Exe file contains program code, software library, OS library. Java, it's a pure Java program. Yes, don't have any OS library. It contains only program code and bytecode for Java library. Yes, exe file is a prepared file for specific OS. Dot class is not a prepared file. It don't have any OS library. Yes, OS library statically linking with OS library. Yes, statically linking with exe file. OS library dynamically linking. Next, exe file is already prepared one. Okay, dot class file is not a prepared one. After moving to OS, JVM prepares as per the current OS. Okay, yes, exe file executes faster than dot class file. Since dot class preparing at runtime, it executes slower than exe file here. Yes, to run exe file, application software is not required to install, but to run dot class file, JDK should be installed. That's it here. So difference between exe file, dot class file. Okay, try this in Google. What's the difference between .exe file, .class file? Just you ask Google, just only will get 2 or 3 points, not this much of information. Okay, so about .exe file, .class file, that's it. Okay, so this is independent platform. So this is the reason how Java made us independent platform. I think it's clear, right? I hope everyone you understand.
Yes, sir.
Okay, everyone cleared. Yes, reason Java dot class for dynamical linking with OS library by the JVM. Since dynamical linking with OS library by the JVM is independent platform, exe file static linking that is platform dependent. So wherever static linking that is platform dependent, dynamic linking independent of platform. Java, Python, both are dynamic linking. Those are independent of platforms. That's it. Okay. Yeah, that's all for today. Yes, tomorrow's session going for Java installation. So tomorrow Saturday, Java install JDK installation and the setup, Eclipse setup. Yes, all setups tomorrow I'll explain. Yes, next you'll get the Sunday. Sunday utilize for the setup to finish your setups. Tomorrow I'll explain the setups. Okay. On Sunday you can utilize that setup. Sunday just utilize that setup. So just try to finish setup Sunday. Just ready by Monday. Suppose anyone unable to set up, just Sunday you can ping me. Just you can ask me. Yes, anytime I can help you. Okay, just you can ping me in WhatsApp. Yes, I can help you 100%. Yes,
Sir,
any
your
doubt?
WhatsApp number, sir?
Yeah, okay, no problem. I'll give you. Okay, yes. Any doubts, guys?
No, sir.
No doubts, right? Yes, 1 second. Just wait for a minute.